here are some of the basics of EIGRP's hierarchical design. First of all, the network, as you can see here, is broken down into zones. This is topologically defined as part of the network, where inside of a zone we essentially have a failure domain. So what's that mean? Well, what that means is that inside of a zone, which we can see a zone right here, inside of that zone, if we were to have a device go down or a link go down, the impact is sort of minimized outside of the zone. Outside of the zone, they see little to no change. Inside the zone, they can go ahead and reconverge, and perhaps we need to do something like a graceful restart or something along those lines to keep forwarding. But for the most part, what happens inside that zone really isn't going to affect the remainder of the network or the rest of the network. So that's one piece, is a zone. The next piece is a choke point. Now, a choke point is where these zones are interconnected with one another. So we can see our choke point defined right here, and right here, and right here in this topology. So we have three different choke points. Now, choke points are where we're going to aggregate reachability and topology information. This is also the place where you want to summarize across these choke points. We can also apply policy at our choke points. Okay, so that's the second piece of this hierarchical design. Now the third piece is a layer. One of the questions that we ask ourselves when we design this hierarchical EIGRP topology is, how many layers are we going to have? Now, typically, what we end up seeing is 2 to 3 layers. Now, in general, 2 layers is very simple. 3 layers is often preferred when we want to do resource restriction policies. But for traffic engineering, usually we'll see 2 layers. So when we talk about a layer is just a group of zones that are equally distant from the core area of the network. Another term that we want to understand here is the depth of our topology, or topology depth would be a way to say it. What the topology depth is the number of hops end to end. So in other words, how many hops is it from here all the way across the network to here? Well, that's something that we need to understand, because the number of hops generally dictates the number of layers that we see. Now, if we don't really have a limit to the number of or the depth of our network or the number of layers that we have, but if we end up having a more complex network with a very deep network, then generally we're going to have more zones. And then that way, within a zone, we can maintain things a little easier inside of a zone, right? We can limit the impact to the rest of the network if a device or a link were to go down, things along those lines. And again, we just need to decide when it comes to these layers whether we're going to have 2 or 3 layers, or if we need more than that. Again, it's going to depend on the complexity of our network. This is one of the things that you're going to have to decide upon for yourself. There's a balance that you have to strike between the simplicity of the network, the routing. Are we doing optimal routing, or do we just have too many hops, too many layers, too much distance in the path here? And then, are we functionally separating the network in a way that makes sense? So these are the decisions that you have to make, but these are the basic concepts of our EIGRP hierarchical design.